This is a tutorial on how to write chemical equations for single and double replacement reactions. We're going to begin with double replacement reactions. So looking at this equation here, I made up a practice sheet for you. It looks like I misspelled calcium. So disregard the typo, and here we go. So you're going to write a formula for calcium nitrate. So basically there are 3 steps in writing these equations, 3 steps. I'll put the 3 steps right here across the top. The first step is to get the combinations down. And the second step is to write correct formulas. The third step then is to balance the equation. So 3 steps: combos, formulas, and balance. And by combos, that means symbols as well. So I just say combos and symbols. All right, so combos and symbols, then write formulas, then balance. So for calcium nitrate, you'd have calcium and you'd have nitrate. Once again, you're going to need to know these polyatomic ions. Calcium, that's a Ca there. Calcium is a +2 oxidation state. Nitrate's -1. We'll come back and adjust the formula later. Plus sodium phosphate. So sodium phosphate. Again, polyatomic ion. The ATE ending tells you that it's a polyatomic ion. Most polyatomic ions will end in ATE or ITE. Only a couple that end in IDE. Remember that IDE usually means a binary compound, except for hydroxide and cyanide. All right, now in this kind of equation, this is double replacement. If you look over to the right here on this help sheet, which will be linked on this YouTube on the homework page, this help sheet says double replacement reactions, compound plus a compound makes a compound plus a compound. The cations change partners, and they only occur if the product includes a molecule or a precipitate. You remember in the precipitation lab, we had to identify the precipitates. These double replacements also occur if there is a combination of 2 nonmetals that's one of the products, and that's a molecule. The biggest example of that's water. Usually water, if water is formed, the reaction occurs, and that counts as your molecule. All right, so the cations change partners. Remember, the cations are sodium and calcium. So they're going to change partners. On this side, then, we would have the sodium in combination with the nitrate, and the calcium in combination with the phosphate. Now it's time to write our formulas correctly. So we've got our combos and symbols done. Now we're going to go to step 2, write the formulas. So if that's 2 and that's 1, you put a parentheses around the nitrate. Like this. Like that. Then sodium is +1. Phosphate is -3. So we're going to have 3 atoms of sodium to match the phosphate. Sodium is +1. Nitrate's -1. So that formula is okay the way it stands. Phosphate. Did you notice I forgot to put the PO4 on there? So phosphate, again, is O4. So calcium is +2. Phosphate is -3. So we have to look for a common multiple. We'd put a 3 down here. Oops. So a 3. And put a parentheses around the phosphate and a 2 outside the parenthesis. So now we have our formulas written correctly. Next step is to balance. On this one, you notice that there's a 3 right here and put a 3 over here. if you do that, looks like I made a mistake right here. I didn't make a mistake, but I erased my note, so it should have been a 2 there. All right, so if you look over here, you see there are 2 nitrates. If I had to put a 3 here, that would give me 3 sodium atoms to match the 3 over here, but it would also give me 3 nitrates. And the 3 nitrates won't work with the 2 nitrates that are over here, so you've got to go bigger. A little trick on these is kind of look for the more complicated stuff first. Like right here, you see I've got 3 phosphates, excuse me, 3 calciums and 2 phosphates. So I'm having trouble with my pen. You might have noticed that. All right, so there we go. So I've got 3 calcium here and 2 phosphates over here. So go with what you have most of, and look over here, you only got 1 phosphate, you got 1 calcium. So if you put a 3 right here, that gives you 3 calciums. That multiplies the NO3s so that I end up with 6 NO3s. So if I put a 6 over here, I can fix that problem. That gave us 6 Na atoms. There are 3 Na atoms here, so I put a 2 in front of the Nas. That's a 2 right there. Somehow I erased my 3 over there, and I erased my 6 over here. All right, so 3, 2, 6, and I think that balances everything. Because there are 3 calciums, 6 nitrates, 6 nitrates, 6 NAs, 2 times 3 is 6 NAs, 2 PO4s, 2 PO4s, and that one's finished. So that's a double replacement, and that looks like the precipitation lab that we did in class. Now these are single replacement. If you take a look at the guide over here, a single replacement is a single element plus a compound makes a single element plus a compound. So you recognize single replacement because aluminum is a single element, nothing with the aluminum, and hydrobromic acid is a compound. Same is true for bromine and sodium iodide. All right, now let's take a look at the aluminum plus the HBr. So aluminum plus hydrobromic acid. So we have Al plus hydrobromic acid. So hydrobromic means binary acid, so it's hydrogen with bromine. Now if you look back over here at the list, it says that a single element, if the single element can form a cation, it replaces a cation. If the single element can form an anion, it replaces an anion. And in italics, it says that the single element must be more active than the element that replaces. There's an activity series on this list right here. You'll notice that aluminum is higher on this list than hydrogen. Hydrogen's down here. So what that means is, if this was the other way around, if it was hydrogen by itself and aluminum bromide, there would not be a reaction. But since aluminum is higher than hydrogen, it will replace the hydrogen. So we have aluminum with bromine where the hydrogen was replaced, and the hydrogen is pushed out by itself. Remember that hydrogen is part of Brinkelhoff, so it has to be diatomic. Remember the 3 steps: combos and symbols, formulas, balance. Well, we've done the combos and symbols, so step 1 is complete. Now formulas. The aluminum is by itself. In case you're wondering about the charge, you'll look at your periodic table and it'll say a charge on aluminum is 3, but it's really 0 here because it's not combined with anything else. It only has a +3 charge when it is in a compound like over here. So over here it is +3. And the bromine is going to be -1. If you look at your periodic table, it's going to say that there's more than one possible charge for bromine. But bromine is more electronegative than aluminum, so bromine has to accept the electrons from the aluminum. So in that case, it has to be the -1 possibility. Hydrogen's +1, bromine is -1, so that formula is okay. This formula, not okay. So I'm going to put what do I put down there, down below? It's going to have to be a 3. Remember that bromine is -1. Okay, and then hydrogen over here is 0 because it's not in combination with anything else. Again, Hydrogen is part of Brinkelhoff, so it has to be in pairs. So now we're ready to balance. If we put a 3 here to make the bromines match, you can see that I'm going to have a problem with the hydrogen because 3 hydrogens, 2 hydrogens, so I had to go higher. So we go to 6. If you put a 6 there, it gives you 6 H's. Put a 3 over here, gives you 6 H's. Aluminum and aluminum, let's see. Oh, we got to deal with the bromine. So you got 2 times 3 makes 6 atoms of bromine, but that also created 2 atoms of aluminum, so we had to put 2 atoms of aluminum over here. And that is how you do a single replacement. Let's take a look at the next one. So this is bromine. Bromine's part of Brinkelhoff, has to be Br2. Sodium iodide, so NaI. Single replacement. Now take a minute to look at your list. If the single element can form an anion, so look at bromine. Does bromine tend to form cations or anions? It's a nonmetal, so it's going to tend to gain electrons, making it an anion. So what happens is this bromine replaces the iodine, and you end up with NaBr. And the iodine's by itself, and iodine's part of Brinkelhoff, so don't forget I2. This is actually the lab we did in the halogen, this is a reaction that we did in the halogen activity lab, where the top layer would have turned purple in this case because iodine is purple in its elemental state. Bromine was orange and it replaced the iodine, so the top layer turned purple. This was one of the pretty ones. All right, so sodium's +1, iodine's -1. That formula is correct. +1, -1, that formula is correct. So now the third step, balance. 2 Brs, so I need to put a 2 over here, which gives me 2 atoms of sodium, so I put a 2 over here. Okay, and that gave me 2 atoms of iodine, so I have 2 I's, and that completes this one. So that's how you handle single and double replacements. I'll come back with another video for synthesis and decompositions.